Hello everybody, and my name is Narendra Kumar and we are from Narendra Academy. And we are in the playlist of mechanics in physics made simple, physics concepts made simple. Now, till now we have done rest, we have done motion. Rest is rest with respect to a reference frame. Motion is change in position with a reference frame which is at rest. Distance is the actual distance traveled by a body. Displacement is the net distance traveled, that is the shortest distance, the straight line distance from the initial point to the final point. It is a vector. From initial to the final point we have an arrow, and speed is the rate of change of position of distance with respect to time. So speed is equal to distance by time. Velocity is the rate of change of displacement with time. So velocity is equal to displacement by time. We have uniform velocity, but the velocity is constant. It's moving without changing its velocity. It is uniform velocity at every point, not at any point, no point the velocity is changing. We have average velocity. The velocity is changing, but if we take total distance, total S by total displacement by total time, we get the average velocity. We understood that also, and we understood uniform acceleration. So if there is non-uniform acceleration, we cannot get any number, but if there is uniform acceleration, that is the initial velocity is v, the final velocity is v, the change in velocity happens in the time, and at every point the increase in velocity is constant. Every point, you take a previous point and the next point, and the next point to the next point, the increase is constant. So we have an equation for this, three equations: u, v, s, t, and a. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. All these concepts come under the subcategory of kinematics. Kinematics means you are observing a body and you are telling how it is going. But now we come to another subcategory called dynamics. Dynamics means especially about the acceleration. Why a body is accelerating, how a body is moving, what are the causes of motion. So dynamics talks about causes of motion, and there we come to a very, very deep concept, three laws of Newton. Today we will do the first law. So let us assume kinematics is very clear to us, and from here we will step on to understand the whole world, how motion takes place anywhere in the whole universe, and then we will finally understand gravitation, and that will complete our deep core concepts of mechanics. So first we will talk about Newton's first law. Suppose you have a body and you push it on a table. It will go for some distance. Just go for some distance and stop. Now look at the interesting point here. I make the surface smooth and give a push. It will go a further distance. I make it more smooth. It goes even further. Sometimes you can see it also. If there is hardly any friction between the body and the surface, it goes like that. Suppose I make it even more smooth. It will go on going. Now listen to this. If I have nothing, no friction at all, maybe like in space, and I take this body and give it an initial velocity with the force. So I just push it. The body will start moving. It's moving. By itself it can't stop. It will start moving. It is getting no stop. Nothing is stopping it. By itself it cannot stop. It will move. No friction at all, nothing stopping it. It's moving, it will go on moving forever. That is a beautiful concept which was actually seen by Galileo, and which Newton formulated it as the Newton's first law. A body remains at rest if it is at rest, and it remains in motion, that's the concept here, remains in motion if it is already at motion. So initially some force was given and then left. Once the body is in motion, nothing extra is needed to keep it in motion. This was a turning point in the history of physics. A body at rest will remain at rest. A body in motion will continue to be in motion. So the body is going at 10 meters per second velocity in one dimension. We are seeing this. So it will go on in 10 meters per second, 10 meters per second. Nothing is stopping it. Normally, this is a wonder actually. Normally we think that bodies should stop, like automatically. We think that if we push a body, it should stop out. That is why people find it very difficult to understand physics. This is very deep. But I told you it is not easy. Definitely it is simple. It is not beyond you. So if a body is moving in space, it goes on. That is why in space, once some motion is given, it keeps on moving like that. So this straight line motion is never going to stop. This is called by a special name called inertia. Let us see rest also once. Normally I ask students like, this body is here, I am not pushing it, why is it falling? Then they tell me gravity, the pull of earth. I say fine, but what if the gravity is not there? What if I take this body to space and slowly leave it? It will be there, I can't even say it will float, there's nothing there. The word float also is wrong. The word hang also is wrong. It be there. So a body at rest will remain at rest. A body is at rest, it will remain at rest. Even if you take this off in space, no pull is coming to it, it will remain there. So this is not such a simple law. So the law says a body will remain at rest, it will remain at rest if it is at rest. That is inertia of rest. This is a lovely word, inertia of rest, which means inertia, the English meaning of inertia, kind of laziness, not moving, like there. So a boy says, I'm not going to study, I'm going to sit here. So he's like inertia. So this is also like an inertia. He says, I'm not moving. Then you have to push it to move, make it move. Inertia is a lovely word. There are some words used in physics also are very, very exact, beautiful words. So inertia of rest. And this is called inertia of motion. So these two concepts are actually not that difficult to grasp if you put your mind and heart and understand the concept. So I finally state again, inertia of rest, the first part of the first law is a body remains at rest if it is at rest. Inertia of motion is a body keeps on moving once given a motion. If there is no friction, it will go on moving, go on moving, go on moving. Okay. So this is it goes on moving in a uniform motion in a straight line. So a body, once in a motion, it goes in a uniform velocity or uniform motion in a straight line. Even to change direction, you need force. I'm going like this. If I want to go that way, I have to give some force. So, actually in nature, in the whole universe, if a body is at rest, it will remain at rest. If a body is in motion, normally we think otherwise, but no. If it is in motion, it will not stop. It is stopping on earth only because wherever you go in earth, you will always find some friction. Okay. So that is the simple concept. Now I think the concept has become completely clear. Once this concept becomes clear, students find it, they like it. They say, this is nice. This is something clear cut. That's all how you have to understand physics concepts. In the next lesson, we'll come to Newton's second law and we'll inquire into, okay, a body is moving with uniform velocity. When does it change its velocity? By itself, it can't change its velocity. What is that which changes its velocity and how does it change it? Then we come to two more concepts, mass, not weight, mass and force. Newton's second law. And then Newton's third law is the action-reaction law. These two laws we'll see in the next video. Thank you so much. This is Narendra Kumar and we are from Narendra Academy.